Okay, this is number 10 in section 4.6, and we're to use the variation of parameters method to solve the differential equation y double prime minus 9y equals 9x e to the minus 3x. And so the first thing we do is we solve the homogeneous equation. And to do that, we look at the associated quadratic equation, which factors out into m plus 3 times m minus 3 being 0, and so then I know that m is 3 or m is minus 3. So that then tells me what my y1 and y2 are. So I have, say, y1 is e to the 3x, and y2 is e to the minus 3x. Okay, so at this point we're going to look for u1 prime and u2 prime. For that, we'll need the Wronskian of these y1 and y2, which is going to be the determinant of e to the 3x, 3 e to the 3x, and e to the minus 3x, and then we take its derivative and get e to the minus 3x. And so here we get minus 3, which is then equal to minus 6. Now we also need the associated determinants a1, which is going to be 0, 9x e to the minus 3x, and then in the second column e to the minus 3x minus 3 e to the minus 3x, which is going to be minus 9x e to the minus 6x. Okay, and then a2, which is going to be the determinant of e to the 3x, 3e to the 3x, and then 0, 9x e to the minus 3x. And this one now is going to be just equal to 9x. Okay, and now we go ahead and find what u1 prime and u2 prime are. And so u1 prime is going to be minus 9x e to the minus 6x over minus 6, or 3/2 x e to the minus 6x. u2 prime is going to be my a2 over w, and so that is just going to be 9x over minus 6, or minus 3/2 x. Okay, so the last step we have to do is find what u1 and u2 are. So u1 is just going to be the integral of 3/2 x e to the minus 6x dx. And so if I let u be x and dv be e to the minus 6x, then du here would be 1, and v here would be minus 1/6 e to the minus 6x. And here, of course, I mean dx in these two places. Okay. And so then I know that this integral here of, I can pull out the 3/2, and then I know is minus 3/2 times uv, which is minus x over 6 e to the minus 6x minus the integral of du v. And so that's just going to be minus 1/6, so that'll change that to a plus. Integral of e to the minus 6x dx. And this is going to be 3 over 12 minus x e to the minus 6x plus, and then here again I get a minus 1/6 e to the minus 6x. Okay, and that's my u1. This of course here is 1 over 4. And u2 is the simpler integral. This is just going to be the integral of minus 3/2 x dx, which is just minus 3 over 4 x squared. Okay, and now we can go ahead and write our yp, which is going to be u1 times y1 plus u2 times y2, and our yc, which is going to be c1 e to the 3x plus c2 e to the minus 3x, and substitute it in here. We'll get u1, which is minus 1/4 x e to the minus 6x minus 1 over 24 e to the minus 6x. That's my u1 times y1, which is e to the 3x plus u2, which is minus 3/4 x squared times y2, and y2 is e to the minus 3x. Okay, and so now our solution then is yc plus y sub p. And this is a long equation, but we have both parts here. So c1 e to the 3x plus c2 e to the minus 3x plus, now let's see, if I multiply this e to 3x in here, I get negative 1/4 x e to the minus 3x minus 1 over 24 e to the minus 3x minus 3/4 e to the minus 3x, sorry, x squared here. Okay, and this is the solution.